In this short video, I present my paper entitled Photochromic and Luminescent Materials for the Development of Chemical Artificial Intelligence, published in Dyes and Pigments of Elsevier. What is chemical artificial intelligence? It's not artificial intelligence in chemistry. Chemical artificial intelligence is the interdisciplinary research line that uses molecular, supramolecular, and system chemistry to mimic some performances of human intelligence, primarily in wet web. There are two strategies for its development. One strategy consists in processing either Boolean or fuzzy logic through chemical systems. The second strategy consists in devising modules for chemical robots. A chemical robot is a confined molecular assembly that reacts autonomously to its environment through molecular sensors that collects data about the environment. The chemical robot makes decisions by its intrinsic artificial neural networks and performs actions upon its environment through molecular effectors. The intelligent activities of a chemical robot should be sustained energetically by a metabolic unit. Chemical robots should be easily miniaturized and implanted in living beings to interplay with cells or organelles for biomedical applications. They should become auxiliary elements of the natural immune system. In the paper I'm presenting in this video, I show how photochromic and luminescent compounds can be exploited to develop chemical artificial intelligence. Any photochromic compound responds to an excitatory UV visible signal by changing structures and color. Here, I show the example of a spiroxazine that is uncolored and becomes blue upon UV excitation. The transformation is reversible. After discontinuing the UV radiation, the initial molecular structure is restored, and the initial state's recovery usually requires tens of seconds in the case of thermally reversible photochromic compounds. Luminescent compounds respond to external UV visible signals by emitting light from their electronically excited states. The recovery of the initial state usually occurs in a few nanoseconds for organic fluorescent compounds. In this paper, you will find that photochromic and luminescent compounds are exploited to mimic the dynamics of neurons in excitable, oscillatory, and chaotic regimes. They synchronize through optical signals. They allow the development of neuromorphic engineering based on optical signals. Finally, in this paper, I show how photochromic and luminescent materials are exploited to process fuzzy logic, which is a good model of human capability to take decisions using natural language. Fuzzy logic can be processed through microheterogeneous systems, system chemistry, and analog input and output relationships. If you want to know more about what I said in this abstract video, I invite you to read my paper on dyes and pigments. Just click on the link below.